So for our first lesson in trigonometry, we're going to be talking mainly about angle measures. And so the first thing that we need to look at is angles in standard form. So an angle is in standard form when it's on the coordinate plane and the vertex is on the origin and one ray lies on the positive x-axis. So here in our example, we have the vertex on the origin, and then we do have one ray on the positive side of the x-axis. So this is actually what is called the initial side of the angle. And so that is that ray on the x-axis. And then the other ray is called the terminal side. So this is where the angle ends, and if you think terminal goes with terminate, terminate means to end. That might help you remember the names. So then we have one last ray, and it's here in the middle. It is what we call the directional ray. So that directional ray is the ray that shows which way your angle is opening, if it's opening as it goes to the left or to the right, or clockwise and counterclockwise. So clockwise rotations do result in negative angle measures, and counterclockwise rotations result in positive angle measures. So if you think about it this way, you are going to go counterclockwise if you're going through those quadrants in order. So I'm going to go down here because I've written enough up there. So quadrant 1 is this first quadrant that we would go through, then quadrant 2, quadrant 3, and then quadrant 4. And then a clockwise rotation is going to go through those quadrants backwards, and that's why it's negative. So we do measure angles in degrees, and that is the most common unit. And the degree is equivalent to 1/360th of a full rotation because there are 360 degrees in a full circle, because that's what actually takes us all the way back around to where we started in the circle. So let's go ahead and sketch some angles in standard form. So we're going to first draw our initial side. It's always on the positive part of the x-axis, so it goes to the right. And then we know 65 degrees is going to be in quadrant 1. And one thing that helps us out is if we look at the circle that we had up here before, you see that once we get up to the y-axis, that is actually 90 degrees. So if we kind of put that on there, we know we need to be less than 90. So it's a little over 2/3 of the way. So we're just going to estimate, draw that directional ray. And there we go. We have an angle at 65 degrees. So then the negative 210, we're going to, of course, start with our initial side. And then we're going in the negative direction, so we're going clockwise. So that means that this first y-axis down here will be negative 90, and then negative 180, and then we'll have a negative 270. So we will need to go past 180, and then in the quadrant 2, about a third of the way. And then we will draw our directional ray to show which way we went. Okay, so let's go ahead and move on to radian. So a radian is a unit of angle measure based on arc length. So 1 radian is defined as the measure of the angle formed with the radius when it is equivalent to the length of the intercepted arc. So if theta equals 1 radian, then it is going to be that the intercepted arc is congruent to the radius. So one thing that might help you convert to radians is to get the comparison to 360 degrees and 180 degrees. So if we think about the circumference of a circle being 2 pi r, then that means that 360 degrees should be 2 pi, because we'd be taking out the radius. And then 180 degrees would then be half of that circle. So it would just be pi radians. And so to convert from degrees to radians, you are going to take the degrees and you will multiply it by a ratio of pi over 180. Or if you want to convert from radians to degrees, you will flip that ratio over and you will take the radians and multiply by 180 over pi. So let's look at some examples. So first we're going to convert 60 degrees. So we will take our 60 and then we will multiply by pi over 180. So since we are dealing with fractions, you could just multiply straight across, but one thing that might help make things a little bit shorter is to cross reduce. And so I can actually divide 180 by 60, and that's going to leave me with 3. 60 divided by 60 is 1. So that leaves us with pi over 3. And so that is my final answer here. So number 4, we have 160 degrees. So we're going to take that 160 and we're going to multiply by pi over 180. And again, I can cross reduce because 160 and 180 are both divisible by 20. So 160 divided by 20 is 8. 180 divided by 20 is 9. That leaves us with 8 pi over 9. And then the negative 45, again, we will multiply by pi over 180. And so the negative 45 can go into 180 4 times. So that gives us 4, and then a negative 1. So we have a negative pi over 4. And now we're going to convert the other way. So we're starting with radians and we want to convert 2 degrees. So we'll take 5 pi over 18 and we'll multiply by 180 over pi. So to make things a little bit easier, we're still going to cross cancel or cross reduce. We can cancel out the pi's. And then 18 and 180 can cross reduce because 18 will go into 18 once, but 18 will go into 180 10 times. That leaves us with 5 times 10, which is 50 degrees. Then on number 7, we're again going to multiply by 180 over pi. And we will do the reducing that we can. So the pi's go. And then 9 will go into 180 20 times. So we're left with 11 times 20, which is 220 degrees. Okay, and then negative 19 pi over 12. Multiply again by 180 over pi. And those pi's will cancel. And then 12 goes into 180 15 times. So 180 becomes 15, 12 becomes 1. And then we have a negative 19 times 15, which becomes negative 285 degrees. Okay, so now we're looking at coterminal angles. So coterminal angles are angles that are in standard position and have the same terminal side. So they end in the same place. So for example, over here we have 90 degrees or pi over 2, and that has a terminal side here on the y-axis. Well, it is coterminal with negative 270 degrees, because if I go from the positive x all the way around to negative 270, I have the same terminal side as the positive 90. Another way to check this algebraically is to actually take 90 and then subtract 360. And that leaves me with a negative 270, which is the degree that I wound up with. I could also take negative 270 and add 360 to it, and that gives me a positive 90. So there's 2 ways to go about this. So on our next examples here, we got to determine whether the 2 angles are coterminal or not. So we have 305 and negative 55. And so what I'm going to do is I'm going to take that 305 and I am going to subtract 360. One reason why I'm choosing to subtract is because the angle I'm trying to get to is smaller than the one I'm starting with. So subtraction makes sense. And when I do subtract, I get a negative 55. So yes, these are coterminal. So on number 10, we have 30 and negative 170. So I'm going to take the negative 170. And since 30 is bigger, I am going to add 360. And when I add these 2 together, I get 190. So that is not the 30 that I'm looking for. So no, these are not coterminal angles. So you can also find coterminal angles by adding and subtracting 360 or any multiples of them. So we are going to do that now with these next examples, just to give one positive and one negative for each. So with number 11, I'm going to take 150 and I'm going to add 360 degrees to it. This gives me 510 degrees. So that is a positive coterminal angle. And then I am going to subtract 360 degrees to get a negative 210. So that is a negative coterminal angle. And then 510 and negative 210 are actually coterminal to each other, just so you know, because all three of these angles end in the same place. And then on number 12, we have a negative 25. So I'm going to take it and I'm going to add 360. And that gives me 335. So that's positive. And then I am going to subtract 360. So that gives me a negative 385. So these two angles are coterminal with negative 25, and they are coterminal with each other. So number 13, we are doing the same thing, but now it's in radians. So remember, 360 in degrees is equal to 2 pi in radians. So what we will need to do is we will need to add and subtract 2 pi instead of 360. So we'll take pi over 12, and we will add 2 pi. Well, we need a common denominator in order to add. So we'll take pi over 12, and then we'll make our 2 pi 24 pi over 2, or over 12, to make that an equivalent fraction. And so pi plus 24 pi is 25 pi over 12. Then we're going to subtract. So we'll have pi over 12 minus 2 pi. Of course, that 2 pi can be 24 pi over 12. And then that's going to give us a negative 23 pi over 12. So for number 14, we have a negative 11 pi over 18. And we're going to add 2 pi. So that 2 pi is going to become 36 pi over 18. Which gives us 25 pi over 18. Then we need that negative answer. So we'll take that negative 11 pi over 18 we started with, and we will subtract 2 pi. So that gives us negative 11 pi over 18 minus 36 pi over 18. And that equals negative 47 pi over 18. Okay, so for the last part of this lesson, we're going to switch gears just a little bit, and we are going to be converting our angle measures into DMS form, which is degree minute second form, and decimal form. So you will see this whenever you are looking at an older map or looking at coordinates. Most of the time online, you will see decimal coordinates, but there are still quite a few things that are given in DMS form when you're looking at a map or when you're looking at older land surveys, things like that. So this is a skill that is definitely needed. And actually, when you look at lines of latitude and longitude, they are also given in what we call DMS form. And so to convert back and forth to understand what's on Google Maps, this is a good skill to have. So in DMS form, 1 degree equals 60 minutes. So you can kind of think it in the same value as time, just instead of hours, you have degrees. And then 1 minute is 60 seconds. And just for the sake of the math later, 1 degree is going to be 60 times 60, which is 3,600 seconds. So your degree is given with that little kind of floaty circle. A minute is 1 apostrophe after the number. And then seconds is given with 2 apostrophes after the number. So to convert decimals to DMS form, you're going to lop off the decimal. So the degree part is going to stay. So we'll take the 0.875 that we have right here, and we'll multiply it by 60. Okay, this actually gives us 52.5. Okay, so the 52 becomes the minutes. And then we will use this decimal, the 0.5, to get seconds. So the 0.5 will then be multiplied by 60. And that gives us 30. So 31.875 degrees is 31 degrees, 52 minutes, so 1 apostrophe, and 30 seconds, so 2 apostrophes. In any decimal, left when finding seconds, can be left. Okay, so we are going to write each of these in DMS form. So on 15, we're going to take that 0.48 and we're going to multiply it times 60. That gives us 28.8. So then we will take the 0.8 and multiply it times 60. That leaves us with 48. So we have 15 degrees, 28 minutes, and 48 seconds. So then on 16, we'll take that 0.375 and multiply it times 60. That leaves us with 22.5. So we'll take the 0.5 and multiply it times 60. And that leaves us with 30. So we have 340 degrees, 22 minutes, and 30 seconds. And then for number 17, we'll take the 318 off, and then we'll take 0.812, multiply it times 60, and that leaves us with 48.72. So that 0.72 gets multiplied by 60, and that leaves us with 43.2. So we will leave that 0.2 on the seconds. So we will have 318 degrees, 48 minutes, and then 43.2 seconds. All right, so now we will go ahead and we will convert from DMS form to decimal. And now that we've done one, you'll see that we are pretty much just going to go in the opposite direction. So we will take our minutes first, and we're going to divide by 60. That gives us 0.15. Then we have our seconds. Now, if we think about what we did before, honestly, for seconds, we had multiplied by 60 twice. So we will need to divide by 60 twice, or divide by 3,600. That gives us 0.0139. So these decimals will need to be added together. So we can take the 73 degrees and then add 0.15 for the minutes and 0.0139 for the seconds. And all of that comes to 73.1639 degrees. So now we're going to take each of these examples and write them in decimal form. So we will need to take our 52 for the minutes and divide it by 60. Which gives us 0.8667. Then the seconds, we have 18, and we're going to divide by 3,600. That leaves us with 0.005. Then we will add these together, so we'll have 84 plus 0.8667 plus 0.005. That leaves us with 84.8717. And then that is degrees. Then on 19, we will take our 34 minutes and divide it by 60. So that gives us 0.5667. For our seconds, we'll take 16 and we will divide by 3,600. That gives us 0.0044. Then we will add these decimals to the 8. And that is going to be 8.5711 degrees. And then our last problem for this lesson, we have 253 degrees, 46 minutes, and 5 seconds. So we'll take our 46 and divide it by 60. That gives us 0.7667. And then our seconds, we'll have 5 divided by 3,600. That is 0.0014. So we have 253 plus 0.7667 plus 0.0014. That gives us a total of 253.7681 degrees.